Hello, today we're going to be working a problem with a point force here, shown as a vector. So for this particular problem, we're asked to draw the force vector shown here in component form. So right now we've got a magnitude of 60 pounds, an angle of 15 degrees, and I need to break that down into x and y components. So the first step in this, with any really point force or vector calculations, I usually draw out the triangles. So I've got a triangle here. It's going to be a right triangle, and I know that the angle here is going to be 15 degrees. I know that the hypotenuse of my triangle, that's going to be 60 pounds. And then the vertical part, so if I draw my x and y axes, y, and x would go out this way. So x is going to be horizontal, so this is going to be t sub x, and this part right here, the vertical part, is going to be t sub y. So now that I have this, I simply use some trig identities. So I know that the tx is going to be the adjacent. If I do cosine of 15 degrees, that's going to be adjacent over hypotenuse. So t sub x is simply going to be 60 pounds, or the hypotenuse, times the cosine of my angle, 15 degrees. And that ends up being approximately 58.0 pounds. And then if I do ty, so t sub y, that's going to be my magnitude, 60 pounds, times the sine of 15 degrees, because sine is going to be opposite over hypotenuse. So I end up with 60 times the sine of 15 degrees. And that value ends up being approximately 15.5 pounds. And so with that, I can kind of redraw my diagram. And I'm going to redraw this diagram with the force in vector form. So I've got my box on the surface. I'll draw in the axes again. I've got y. I've got x. I've got my tension force, like so. And I draw in t is going to be equal to, use square brackets for vectors. The x component, so 58.0, comma, the y component, which is 15.5, and then I do the square closing bracket, and the units for this vector are going to be pounds. So with that, I've converted my original force vector, which is given in terms of a magnitude and a direction, into a force vector that's given in component form with x and y components. So with that, we've finished our problem. Thank you for watching, and I hope to see you again.